Have you ever asked yourself a question, how are scientists able to prove that there is water in a specific region in space, like for example planets or exoplanets? We actually had that released by James Webb Telescope about one exoplanet that potentially have a lot of water in its atmosphere in different forms. And now looking at Perseverance Rover, which was sent over a year ago to Mars to explore a specific region on Mars and how they're able to target the landing on that particular region at the right place at the right time for this particular image and discovery to occur is really fascinating. And looking at how this is going to be a game changer in not only in terms of understanding the ancient life potentially of Mars, but most importantly how this is going to inspire scientists to figure out multiple diverse ways of searching for the most critical compound that is really important for fostering life in any region, which is water. Now I was exploring the universe in terms of the article world, and I found this article that is titled "First Underground Radar Image of Mars Perseverance Rover Reveals Some Surprise." And I'm like, okay, what are these surprises? I mean, we'll be hearing a lot of these surprises, like for example how this is going to be a game changer in terms of the build up to understanding more about the ancient times of Mars. But this is really fantastic because when you look at it closely, we actually see some connections between a river, a delta, and a crater. And this is really a fantastic region there because potentially there is water, or water was present in that region. Now you might be thinking this particular question: how do you know that water was present in this particular region, and what are the characteristics that might prove to us that yes, indeed, water was present in that particular region? And this is where a couple of interesting tools that are present in this rover actually is critical to understand specific stratas of this particular formation on this region. And it's really mind-blowing to see this actually being analyzed, and also how it is inferred, and finally how this can lead to multiple questions about this particular character of this crater. Now when you look at this particular overview image of this region shows three things. One is we have the Jezero Crater, which is the lake, and this lake must have had deposits of water. Now you might be asking yourself the question, where did this water come from? We notice that there is some kind of streams in the form of a delta that is actually flowing or drawn towards this particular lake from the west end. And so it's really fascinating to see that this delta is actually connected to a main river, as we see to the west of that delta. So it's really fascinating to see how this original river will transfer a lot of deposits that are going to be sent through the delta into the lake, and by so doing we'll be able to analyze how these particular deposits are actually formed, how they are inclined or they are pretty much straight, as we're going to see in further down the article, and what impact did that particular force of nature actually had in the history of this particular lake, and potentially how maybe we might see a couple of things that we've not seen before that proves that water was present, and most importantly maybe life actually fostered in that particular region on Mars. Now the goal of this rover Perseverance is to scan a 30 miles wide of this Jezero crater, and this particular lake, which has potentially fostered ancient life, is going to show us some interesting characteristic based off of the instrument that this Perseverance rover has. And this instrument processes some radar instrument that actually shows a couple of interesting behavior of the Earth formation, or in this case Mars formation. And these deposits of rock in terms of layers can be seen if you apply that on Earth when you're going on a road trip and you see a couple of high mountains or cliffs or rocks formation, and you see different line patterns. All those line patterns tells you the history and also the formation of that particular rock back into the ancient times. And this particular information is really valuable for scientists to explore not only the history but also how this will be a game changer in terms of maybe fossil evidence or specific layer that may be crucial for a region in time where life may have at some point fostered in or on that particular region, or in this case Mars. And so it's really fascinating to see how this particular radar process works based off of this instrument that is called RIMFAX. And according to this particular article, it states how it works, which says that it sends boosts of radar waves below the surface, which are reflected by rock layers and other obstacles. Now, the shape and the density, thickness, angle, and composites of underground objects really affect how the radar waves bounces back and creates a visual image of this and the layers beneath. So now this radar image also reveals a couple of interesting things about the electromagnetic properties and bedrock stratigraphy, and this actually shows the arrangement of rocks of the Jezero floors to depth of how many? Guess? 50 meters and above 49 feet. This is really incredible stuff here in terms of how this actually works. Now to the part that you all have all been waiting for, which is the observation. The observation shows a couple of interesting properties and differences in terms of what we thought versus what is actually what we see. And so what they saw is that yes, indeed, this particular ground that is revealed in terms of the strata reveals an unexpected slope, and this slopes actually shows also how the thickness and the shape of this incline, not straight but incline section, can either be formed one or two ways. Now, one is either slowly cooling of a lava and or in this case deposited as sediments in the former lake. And so this is really fascinating in terms of how this observation wasn't actually meeting what they expected. Like they're expecting more of like, oh, it's smooth, less inclined, and this inclination is actually up to 15 degrees, not really like maybe 4 or 5 degrees. This is like 15, which is a lot of incline. Anytime I bike on a hill, do you know what 15 degrees is? I can't climb a hill with 15. I'm going to have to gear down hard enough for me to make it uphill. That is how something you should think about in terms of 15 degrees. And so this here led to concluding statements like what? Like they said that they were expecting to see horizontal rocks on the crater floor, and the fact that they are tilted like this requires more complex geological history in this particular region, and they could also be formed when molten rocks either rose up towards the surface, or alternatively they could represent an older delta that deposited buried in the crater floor. So was this delta or lake formed by lava flowing from a particular eruption volcanically, or is it actually from water that is flowing down from the river to the delta to the lake? This is really fascinating to see this conclusion being made, but then they still have to explore more about this delta. So now they are moving a little bit away from the Jezero Crater to more of like, hey, let's check out this delta and see the characteristics of this delta and how is this going to imply our understanding of this formation of this lake, and if the delta gives invaluable information and more questions, then they can move into the main lake and see whether this might be the rocks are actually formed igneously or sedimentally, according to this particular article. And this article actually touches on that particular statement that the evidence points to an igneous or molten origin, but based on the RIMFAX data, this team couldn't tell or say certainly how the inclined layers that were formed. And so, or another question might be this: was the lava formed first when it cooled and solidified? We had deposits of different stratas of lava, and then later water was created, and that actually helped also as well in the cooling process of that lava. Now let's know your thought about this in the comment section down below, and something to watch out for in terms of this particular critical region that may have fostered ancient life. And the big question that has been answered: how do we detect the behavior of water in different landforms or planetary systems? And this is another way of actually checking that out, using this particular instrument and looking at the bed formation of various planets or segments of a planet that may have fostered ancient life. And I hope you found this really informative. Please hit a comment down below. Let me hear your thought about this particular article. Do you think that there is more to this particular article, or do you think that this is a dead zone? All the same, I hope you found this informative. See you on the next one. Stay smart as always, and believe in yourselves.